This is on mathheals.com if you want to go here to get more links for YouTube videos in various math subjects. And this section we're looking at the law of cosines. Well, let's look at the formulas. So law of cosines. Got three forms of it. Cosine of angle A is equal to b squared plus, these are our sides, little b squared plus little c squared minus little a squared over 2bc. We have cosine of b is equal to a squared plus c squared minus b squared over 2ac. And cosine of angle C is equal to a squared plus b squared minus c squared over 2ab. Now these are the formulas that are always given you every book. How useful are they? It's probably questionable. You can use these to derive them into the forms, which are a lot more useful. So let's talk about that. I've went ahead and solved those formulas. On the left side, I've solved them for the sides. So side A is equal to square root of b squared plus c squared minus 2bc times cosine A. Side B is equal to square root of a squared plus c squared minus 2ac times cosine B. Side C is a squared plus b squared minus 2ab times cosine of angle C. Now on the right side, I've solved them for the angles themselves. So angle A is equal to inverse cosine b squared plus c squared minus a squared all over 2bc. Angle B is equal to inverse cosine of a squared plus c squared minus b squared all over 2ac. And angle C is equal to inverse cosine of a squared plus b squared minus c squared all over 2ab. And let's use these to solve some problems. Okay, so we got A is equal to 70 degrees, and side B is 10. Let me write that so you can read it. Excuse me. And side C is 18. Now, in order to use the law of sines, you have to have two of something, two A's, two B's, two C's. We don't have any of that here. We actually got an angle with it's enclosed by two different sides. So the law of sines fails. Of course, this isn't the right triangle, so we can't use that. So then we have to go to the law of cosines. So we're going to look for a formula that has angle A and sides B and C. Angle A and sides B and C. Well, this first one does. So we can find side A using A is equal to square root b squared plus c squared minus 2bc cosine of angle A. B squared, so we got 10 squared plus 18 squared minus 2 times 10 times 18 times cosine of 70 degrees. Okay, so let's plug that in the calculator. Okay, so I got square root, so do second x squared, 10 squared plus 18 squared minus 2 times 10 times 18 times 10 squared plus 18 squared minus 2 times 10 times 18 times cosine 70 degrees. So cosine of 70. And enter. I'll take it 2 decimal places. 17.35. Now, you want to make sure you're in degrees. If you're not, If you didn't get that answer and you typed in exactly as I did it, go to your mode, down arrow to the third line, right arrow, and highlight degrees. Now we came up with this answer here, and I want to find B and C. In order to find B and C, I have to do one of two things. Use the other formulas for law of cosines or flip back to law of sines. I'm going to use the other formulas for law of cosines, but I need to save off this value because this is an approximate. It's rounded. So if I can find my calculator, I'm going to save off this. Now this was side A. Unfortunately, there is no lowercase a, so I'm going to store this. So I press store, and I do alpha math, and I'll throw it into capital A, like that. Okay, so let's come over here. Now we're going to find, let's say, angle B. I think the law of cosine formulas are so easy, you might as well just keep using those. So here's our formula for B. And you have to know A, B, and C for this formula. Well, we got B and C up here, and we got A here. So we'll use that formula. So B is equal to inverse cosine of A squared plus C squared minus B squared over 2AC. So we have the inverse cosine of A squared, so I got a 17.35 squared plus C squared, so 18 squared, minus B squared, so minus 10 squared, over 2 times A, so 2 times 17.35, times C, which was 18. Now the trick to putting this in your calculator correctly is when you put it in there, put parentheses around the top, put parentheses around the bottom. So let's go do that. Okay, so I'm going to do second. What am I doing? It's inverse cosine. Okay, second cosine. And then we'll do a beginning parentheses for the top part. 17.35 squared. Now I don't want to put that in. Remember, I stored that in A. So I'm going to do alpha math to get A squared plus 18 squared minus 10 squared. Closing parentheses on the top part divided by beginning parentheses on the denominator. Then 2 times 17.35 times 18. Closing parentheses on top part, closing parentheses on inverse cosine. And enter. I didn't want to put A in there. Let me try it again. Do second, enter. Remember, we don't want to put in 17.35. We want to put A in there. A little bit of a screw up. Okay, so alpha math. Now, A is still an approximation, but it goes out there many, many decimal places. So we press enter. Now look what we came up. Look at the difference. I put in an approximate here, and I got 32.82. And here I put in the out to, like, I don't know how many decimal places the calculator goes to, but quite a few, and it's 32.80. So do not use rounded off values if you can help it. Okay, so this is 32.80 or just 8 degrees. Well, now our other missing thing is angle C. Well, angle C is equal to 180 degrees minus A minus B. Well, A was 70 and B was 32.8. So angle C is going to equal to 180 minus 70 minus 32.8. And we get 77.2. Okay, why was it okay to use a rounded off value here and not up here? Well, I knew I wanted these to add up to 180 degrees. So that's why it was okay to use it here. It's because I want them to add up to 180. I know I'm going to round this one decimal place anyway. Up here, it makes a big difference. You saw that. Comes out in the hundreds place, so wrong. So those would be our answers. Again, solving the triangles, finding your missing angles, sides. Let's take a look at our second example. We've got A is equal to 9. And B is equal to 5. And C is equal to 10. So we know the three sides. Come back up to my formulas up here. Excuse me. If I come over here, these formulas, all three of them, require you to know the three sides, which we know. So we can plug them in directly here and find our angles A, B, and C. So let's find A first. A is equal to the inverse cosine of B squared plus C squared minus A squared all over 2BC. 2BC, yeah. So I got 5 squared plus 10 squared minus A squared, which was 9, so 9 squared, over 2 times 5 times 10. So we got inverse cosine. And it's probably beneficial to do a little bit of math here to simplify it. 5 squared is 25, plus 10 squared is 100, minus 9 squared is 81. These are decimals, I wouldn't do that. 2 times 5 is 10, times 10, it gives you 100. The key to plugging this in is if you got a fraction, and you got more than a single number on top and or bottom, you have to put parentheses around that top or bottom. Well, we got more than a single number up here, so I'll put parentheses around that, like that. Okay, let's plug this in our calculator. So I'm going to do inverse cosine. Beginning parentheses on the top part, 25 plus 100 minus 81. Closing parentheses on top part divided by the bottom part, which was 100. And closing parentheses on inverse cosine, and enter. And we get 63. Two decimal places, 90, or just 9. And that's our angle. Well, let's find B. From our formula, B is equal to inverse cosine of, now notice the pattern here. This is A, so this is the other two variables. So this is B, so this will be A squared plus C squared minus B squared over 2AC. Okay, so A was 9, so we got 9 squared plus C, which is 10, so 10 squared minus B, which is 5 squared, over 2 times A, which is 9, times C, which is 10. Do a little bit of simplifying before we plug it in. 9 squared is 81, plus 100 squared, which is 100 squared, plus 10 squared, which is 100, minus 5 squared, which is 25. 2 times 9 is 18, times 10 is 180. Again, the key to this is if you have more than a single number on top and or bottom, you have to put parentheses around that. We don't need parentheses around 180 because that's just a single number. So inverse cosine, beginning parentheses on the top part, 81 plus 100 minus 25, closing parentheses on the top part divided by 180, and then closing parentheses, and enter. So we got B is equal to 29.93. did I say? 29.93 degrees. Taking 2 decimal places. Now, assuming that I've typed these in correctly into the calculator, which is always kind of iffy. I'm looking through any errors. I don't see any, but that doesn't mean anything. Assuming I've done that, then C is easy to find because it's 180 minus A minus B. Now, you might be sitting there saying, well, yeah, but A and B are approximates. You rounded. Well, that's okay in terms of degrees because I want them to all add up to 180 degrees. Sure enough, if you don't, then you'll have some joker that sits there and adds them up and says, hey, where's that missing 0.01 degrees? So I've got 180 minus 63.9 minus 29.93. And then enter. And we get 86.17 degrees. Okay. Now our largest angle is C, which is our largest side. Our smallest angle, B, which is our smallest side. So that kind of seems to tie. Let me save this and we'll look at our last problem. Trig, law of cosines, part 1. I haven't worked a whole lot of these examples because I think it's pretty obvious. Not too hard. Let's see, A is 9. Is this the same as the previous one? Okay, no, I'm famous for that, so I thought I better check. B is 8, and C is 11. Okay, back to our formulas. Obviously, these ones on the right are the perfect ones because these over here you have to know some of the angles, which we don't know any angles, so we have to use these. Okay, so for angle A, it's equal to inverse cosine of B squared plus C squared minus A squared over 2BC. So we got inverse cosine, B squared, so we got 8 squared plus C squared, so 11 squared minus A squared, so minus 9 squared, over 2 times B times C. So 2 times 8 times 11. Do a little bit of simplifying before I plug this in my calculator. 8 squared is 64, 11 squared is 121, minus 9 squared, which is 81. And it's like 2 times 88. I guess I won't do much simplifying there. I probably get it wrong. I think it's 176, but we'll just go ahead and put it in the calculator. Put parentheses on top, and since we have more than a single number downstairs, we'll put one parentheses around that too. So let's see. Inverse cosine, beginning parentheses around the top part. 64 plus 121 minus 81. Closing parentheses on top part divided by beginning parentheses. 2 times 88. And closing parentheses on bottom part, closing parentheses on inverse cosine. Enter. And we get 53.78 degrees. Okay, so let's find B now. And again, we'll use our formula, inverse cosine. So we're going to have A squared plus C squared minus B squared over 2AC. So we have inverse cosine. A, so we got 9 squared plus 11 squared minus 8 squared over 2 times A times C. I'll do a little bit of simplifying before I plug it in. 9 squared is 81, plus 11 squared is 121, minus 8 squared, which is 64. And this is 2 times 99. Again, key is put parentheses on top, parentheses on the bottom. Okay, so second cosine, beginning parentheses on top, 81 plus 121 minus 64, closing parentheses on top, divided by, beginning parentheses are on the bottom, 2 times 99. Closing parentheses on the bottom, closing parentheses on inverse cosine, and enter. And we get 45.82, rounding 2 decimal places. Now for C. C is equal to 180 degrees minus A minus B. And again, I'm going to use approximations here because I want them to add up to 180. So 180 minus 53.78 degrees minus 45.82 degrees. So we've got 180 minus 53.78 minus 45.82 and enter. And we get 80.4 degrees. Okay, that's our largest angle, and side C is our largest side. Our smallest angle is B, and that's also our smallest side. So that kind of checks there. Now let me save this. And that's the end of that section. So we stop the recorders.